Hello everyone, this topic is about even and odd functions. Number 1 says the function f of x equals x cubed plus 3. Is it even, odd, even and odd? There's nothing called even and odd, so just exclude this one, or neither even nor odd. Okay, by looking at the function without any step, I would say this is a neither even nor odd. Why? Because it has an odd power and a number. Whenever you see odd powers and a number, then it's neither. Whenever you see an odd power and an even power together, it's also neither. You can do the tests f of negative x. You will realize that this is going to change sign and this will not change sign. So it does not follow any of the tests of the even and odd. But again, without any steps, just look. If it's an odd power and I have a number, remember it's neither. Number 2, determine the type of the function. Here I have an odd power and an odd power, so definitely it's just odd. If you do the f of negative x, this will change sign and this will change sign. So everybody change signs, so it's odd. By looking, if they're all odd powers, it's an odd function. This function has an even power and a number. It is even, because with the even power and a number, there's no problem. But an odd power and a number, it's neither. Even power and a number, it's even, because if you substitute f of negative x, this will stay x to the power 4 because it's an even power, and this will stay as it is, the same sign. But without in the tahsili test, there's no time. You don't need to do substitution. Just look. It's all even powers, it's even. It's all even powers and a number, it's even. Even and odd, it's neither. Let's check number 4. The function here, odd power, odd power, odd power, and I don't have a number. So it is an odd function. If they added a number over here, I would have went to neither. If one of them was an even power with the others are odd, I would say neither. But all of them odd directly, it's an odd function. Number 5, determine the type of the function. f of x equals 2x minus x to the power of 4. This is an even power and an odd power. So what do you think? When they come together, it's neither. This function, negative 6x to the power of 2 plus 5, an even power with a number, there's no problem. It is an even function. Here, odd power, then it is an odd function. And odd functions are symmetric about the origin. From the opposite graphical representation of the function f of x, then f of x is what? What do you think this function is what? It's symmetric about the origin, right? When we rotate it 180 degrees, it will go back to the same shape. This is symmetric about the origin, and so it is an odd function. And this function, again, it's an even power and an even power. Even if there's a number, even there's plus 2 or plus 3 or any integer, still an even function because all the powers are even. I hope I made it clear for you. So the topic is about limits and continuity. The first question, what type of discontinuity does this function represent? At x equals 1.5, which type of discontinuity? First of all, there's no type of discontinuity called undefined. So this is out. Secondly, as you can see, it's a whole discontinuity. There's a whole over here at x equals 1.5. This function is undefined. So whenever you see such figure, this is called removable discontinuity or whole discontinuity. The second question, the function that represents an infinite discontinuity. This is removable. This is jump. This is a continuous function, and this one is infinite discontinuity at x equals to c. You can imagine an asymptote over here, or you can imagine that this is an infinite. This is going to infinity, and this part of the graph is going to negative infinity, not to a specific number. So the limit over here does not exist, and this is infinite discontinuity. For what value of a will the function f of x be continuous at x equals to 4? So we understood that the function is discontinuous at x equals to 4. Here is a piecewise function. The first function, x squared minus 16 over x minus 4, where x is not equal to 4, and a, where x is equal to 4. Remember when we took in Algebra 2 the removable discontinuity, when I used to tell you when you cancel two factors from the numerator and the denominator, there will be a whole at x equals to whatever, that when we set this equals to 0, there will be a whole at x equals to 4, because we will not forget that this function, its domain cannot include x equals to 4. Although we can, after factoring x squared minus 16 using difference of squares into x minus 4 times x plus 4, and then cancel x minus 4 with x minus 4, I can draw this function x plus 4 peacefully, but I cannot draw it as a straight line, forgetting that there is a whole at x equals to 4, because the original function x equals to 4 is not in its domain. No way, I cannot divide by 0. So if you substitute the 4 over here, you will get y equals to 8. So we want a function over here that's called y equals to, or f of x equals to 8. So when x equals to 4, y equals to 8. This will cover the hole that's drawn in this graph. Did you understand me? So when you draw the line x plus 4, you will find a hole at x equals to 4 and y equals to 8. Now this point will cover it. This point says that f of x equals to 8 when x equals to 4. So we must choose 8 to cover, because the question said for what value of a is y. It's just the function y. It's the value y. And for example, this is y equals to 8, or y equals to 4, y equals to 5. It's just a straight horizontal line. We need it to be y equals to 8 for this function to be continuous at x equals to 4. So it's just a point over here, not a line anymore, a point where x equals to 4 and y equals to 8. Here is a piecewise function. It says if f of x is equal to 4x between 0 and 15, as you can see, 60 between 15 and 24, and negative 6x plus 15 between 24 and 40. And the question is asking you to find f of 5. The question is, in which function shall I substitute the 5? In this function or this function? This function is already, the answer is 60. In this function, you will look where is x equal to 5, in which domain, in which part. So I guess it's clear, it's over here. 5 is over here. So you will substitute the 5 in this function, and then you will get f of 5. So 4 times 5 is equal to 20. The next question, the removable discontinuity, is the removable discontinuity has another name, which is called point discontinuity. The function f of x equals to at x equals to 2 this is a polynomial. Do not substitute. It's a polynomial and it's continuous everywhere. So if you will substitute 2, of course, it will not be undefined, nor discontinuous, nor limit does not exist, because all polynomials are continuous. So the only answer is continuous. If we redefine, again, this is like question number 3. They want to redefine the function f of x equals x squared minus 1 over x minus 1 to become defined at x equals to 1. So it's undefined at x equals to 1 because we cannot have a denominator equal to 0. They want us to make it a continuous function, or basically to close the hole, to cover the hole. This function, no way it's going to equal to 1. X is not going to equal to 1. But I can find out something else. Here, like the previous question, I factored the numerator using difference of squares. And then I can cancel x minus 1 with x minus 1. What is left is x plus 1. Now let's try to substitute the 1 here. What will we get? We will get 2. So we want b to equal to 2. Now there is a hole. If you graph this function, which is f of x equals x plus 1, you will graph it, but you will remember that you have a hole at x equals to 1 with y equals to 2. You must have a hole at x equals to 1 and y equals to 2, because we will not forget that the original function was discontinuous at x equals to 1. So to cover this hole, to make this hole a closed hole, okay, we will have to use when x equals to 1, y equals to 2, or f of x equals to 2. So number 6, increasing, decreasing, constant functions, and extreme values. The function represented graphically in the opposite figure is increasing in the interval. How do you know when is the function increasing? Train your eyes to look as x goes to the right. As x goes to the right, where is y increasing? For this piece, as I go to the right, y is decreasing. For this middle piece, it's constant, right? Nor increasing nor decreasing. From 2 to 3, as I go to the right, y is decreasing. From 3 onwards, as I go to the right, y is increasing. So at which interval do you think the answer is? From 3 to infinity. In the opposite figure, the function f of x is decreasing in the interval. Okay, I will come from the left side and start going to the right. As I go to the right, I know you can see this is going down, and this is the problem. But go to the right. As you keep going to the right, y will keep increasing over here. And then from -4 to 0, y is constant. And as you go to the right from here, as you go, see the y is decreasing in this piece. As I keep going to the right, the y will keep decreasing. So I need to know this interval and not this one, because this one, as I go to the right, y is increasing. So the answer is from 0 towards infinity. What is the interval in which the represented function in the opposite figure is increasing? Again, I'm going to the right. This piece is decreasing as I go to the right. Continue going to the right. Y's are decreasing until 1. Until 1, right? After that, as I go to the right, y starts increasing, increasing. As I go to the right, y will keep increasing. So the trick is in looking as x goes to the right, what is happening to y, and don't look at the arrows. Okay, so the answer is from 1 to infinity. From the opposite figure, the local maximum value is. The local is the maximum value among the numbers beside it. Here there's a maximum, remember, and here there is a minimum. So basically we just want not the maximum point ever, we just want the point over here, which is called a local maximum. And we want the answers over here gave you all the y's at x equals 2. So y equals 2 at x equals to -1. In the opposite figure, the value of f of a in the interval c closed until d. The value of f of a, let's see the answers, is absolute minimum. This a, is it an absolute minimum? Is it a local minimum, local maximum? Anyways, I have to take something from the maximum. Is it a local maximum or an absolute maximum? What's the difference? The difference, local maximum is a maximum, as you can see, the peak of one of the parabolas or one of the curves. But it's not the maximum point in the whole graph. Absolute maximum is the maximum point in the whole graph, which is going to be this point. Okay, so this is just a local maximum. From the opposite figure, the local minimum value of the function So here this is a maximum and here there is a minimum. Okay, so of the function f of x is what? Okay, the local minimum over here is 0. So the answers over here are all the y's. And usually we refer to the maximum and to the minimum using the y. If it's not specified, these are all y's. And anyway, you don't have x, you don't have 1 to think that maybe it is 1. And even if 1 is there and 0 is there, use the y value. The maximum and the minimum are usually referred to using the y values. In the opposite figure, the function f of x in the interval 2 to 4 is what? Where's 2 to 4? What is happening to the function in this piece? First of all, it's not constant nor oscillating. Okay, it's not like a sine graph over here or something going up and down. It's one step, it's going down. But the question is, increasing or decreasing? Go to the right from 2 to 4 and see what is happening to y. Obviously, y is decreasing. Topic number 7, average rate of change. The first question, the average rate of change of the function f of x equals x cubed in the interval -1 to 2. These are both x's, x1, x2, or you can call them a and b. Okay? Now, there is a rule for average rate of change. These, as we said, are considered A and B. The rule for average rate of change is f of B minus f of A divided by B minus A. Over here, it's exactly the same idea of the slope, y2 minus y1 over x2 minus x1. But you don't have the y's, you only have the x's. How will you get the y? You will get the y by substituting 2 over here, and you will get the y by substituting -1 in the function. So f of b minus f of a over b minus a will give you the average rate of change of any function. The second thing, you will have to get f of 2, because our b here is 2, f of 2 minus f of -1 divided by b minus a, so 2 minus minus 1. What is f of 2? 2 to the power of 3. So here is the 8 minus f of -1. Substitute -1 here, you will get -1 to the power of 3 will remain as -1 divided by 3. So your answer will be 9 divided by 3, which is 3. Number 2, again, average rate of change of this function in the interval -8 and 1. As we said, we will consider this, the first one as A and the second one as B, and we will start always with f of B. Now, f of 1 is equal to, f of 1 is equal to 3. Over here, we will get 1 plus 8 root of 9 is 3 minus f of -8, which is 0, divided by 1 minus minus 8, and that is 9. So 3 over 9, the answer is 1 over 3. The average rate of this function, of change of this function in the interval -5 and 3. F of 3 minus f of -5 over 3 minus minus 5. When substituting in this function, you will get the answer as -4. The same procedure for the average rate of change of this function on the interval -2, -1. This is A and this is B. F of -1 minus f of -2 over -1 minus, we get the answer as -4. And this function is asking us to find the inverse function of f of x, which is root of x minus 4. The steps for doing this, we took it in algebra 2. The first step is to exchange y and x. Write x instead of f of x and write y in place of x. The second step is to solve for y. You want to isolate y. So y minus 4 is equal to x squared. Here we squared both sides. And then the last thing, to get rid of the -4. So the answer is x squared plus 4. The inverse function of f of x equals to x minus 1 over x plus 2 is, remember how we used to find inverses in algebra 2? The first step was to change any y into x and any x into
y. So basically I would just label this as x. I'm just writing x over 1, I'll tell you why, equals y minus 1 over y plus 2. Now we are going to cross multiply. I solve this equation or this for y. I want to solve it for y in the end, okay? The next step I will cross multiply, so you're going to get x times y plus 2 equals 1 times y minus 1. After distribution, I'm going to reach this, and after simplification, or actually after taking y as a greatest common factor, I will have x minus 1 equals negative 2x minus 1, and the final thing is to divide over here, so your answer will be negative 2x minus 1 over x minus 1. How will you find the inverse of this function? This sign means inverse. How will you? The first step, I will make this as an x and equal to 2y minus 5, and then solve it for y. So basically y is going to equal to x plus 5 divided by 2, and your answer is A. Again, the inverse of this function, the same steps. I'm just going to remove this and write x, and here I'm going to substitute y and then solve it for y. Basically, this is going to be 2x, right? So I will exclude a because it's 2x, and then plus 5 and all divided by 3 if you want to solve it for y. And the inverse of this function, the same thing, x equals 18 minus 3y. When you solve it for y, you're going to reach x minus 18 divided by negative 3. It's not in the answers, but this is x divided by negative 3 plus 6. So your answer is D.